I also do DevOps. For various reasons, I dabble, or more than dabble, in the DevOps space. And recently, started to get involved in some DevOps tooling and some development tooling and thinking differently about how we do things. So this is what this talk is about. This talk is about containers and how they're actually making life interesting for us, and then what's actually happening in the space, what IBM's doing, what other people are doing in terms of trying to make it a little bit better. So it starts here. Who's got a cloud? I've got a cloud. Yeah. It's what we've always wanted. Cloud, brilliant. We've been looking for cloud since forever. You know, compute on tap, right? But actually, it's not really cloud that we talk about nowadays. We talk about containers. Containers are the things that we deal with. It's not a cloud, it's a container story. That's because you can take containers anywhere. We know that. You can put stuff in a container and it moves around, easy. You can do absolutely anything with containers. You can live in them. These are real Docker shipping containers that, in this case, are houses. Some people turn them into hotels, and you can just live in them. I imagine it's quite cold and echoey to live in a large metal box, but there we go. You can do amazing things with containers. This is real live containers turned into artwork. It's cool, isn't it? And as long as you can get your containers together, you can go on all sorts of new journeys and do new things, right? You can build new solutions. As long as the answer is a container. We have bought into the container model. Now that's good because containers are giving us new opportunities. So we have our old way of structuring applications, our existing, I don't like to use the word traditional or legacy, but the way that we used to do it and the way we still do it. We have very simplistic versions of those where we take the monolith and we stick it in a box and go, hey, it's containerized. Or we do microservices. Or we go further and we do picoservices, microservices, microservices, nanoservices, serverless, all these sorts of things. We are looking at new opportunities, and most of this is enabled by the fact that we rely on containers and that we can deploy them to some cloud. So we're all set for this. People have bought into the idea because of the two words you can see in the middle there, immutability and repeatability. The story is that if you can get a container and you can build it, it will never change, it will behave one way, and you can run that anywhere forever, and there will be no nasty surprises. Okay? It turns out, though, we have some immediate challenges. So it's the cloud, so I've got a rain analogy. So there are little problems coming, right? It's a good story, we're on the right track, it's just not exactly as you may have been led to believe. So to start off with, you want to do all these things. And of course, you don't want to do one of them, you want all of them. Where do you run your containers? Well, you need a shipyard, somewhere to run all this stuff, which of course nowadays is somewhere between Docker Swarm, and Kubernetes. You need that large environment, your large, complicated environment to manage, to host all your many, many containers. Okay. You also need tooling, because once you drop into the container world, you get lots of containers. You have created microservice solutions, you have many of these, and you have many instances of them at different versions, wired up to differently. You have a much more complicated life. And you need tools to manage that. So this is where the rain starts. You know when you want to use some new piece of technology, or maybe you're just interested and you go, what are the top things I should learn? Hey, what are the top 5 tools I should use for Java? And you might just say, tell me what are top tools to learn. And you'll get something on Google and it will say top 5, top 3, top 20 if you're really unlucky. And you go, okay, these are the things I have to learn. You do this for Kubernetes as an example, and you get this. The top 50 tools. And I'm not kidding. So you should go have a look at this, because these are all important tools. You want to have a wander through the list of tools that you as a developer may find yourself having to get connected to because of the environment we're deploying to. You think 50 is a lot? How about this lot? Anybody seen this picture before? Yeah, okay. Most people are going, yes, I've seen this picture before. This is the Cloud Native Computing Foundation's take on the tools in the space, right? And they're trying to organize it. If you walk through this, you will find lots of tools, and you will read them and you go, okay, I understand what you're for. I understand what you're for, I understand what you're for, I understand. This is the space that we're in, okay? So, complicated number of tools, and more consequences of what we've done in terms of adopting containers, just jumping in. Quite often, containers don't actually contain what we think they contain. They contain rubbish, trash. They don't behave as we expected. And the reason is because you as a developer do it one way and your build process does it another way, and you get into all sorts of horrible messes. And of course, debugging inside a container, is that easy? No, that's hard, okay? It's tough being a developer, isn't it? You have to make all these choices. You have to decide what you're going to have on your desktop. Linux, Windows, Mac. Cool. Then you have to decide what version of Java you're going to use. Okay? Then pick a framework. Got to pick something. And then you have a build cycle. And you make choices there. Whether you use Maven or Gradle or something else, and do you put it into Git or whatever, you have those choices, right? And then you add in the IDEs you're going to use, like IntelliJ or Eclipse or VS Code. And then you've got test tools. What test tools do you add? And what databases? And maybe you've got some mocking stuff you want to put in there. And maybe your IDE's got special tools like find bugs or something. And you add all that is your life now as a standard Java developer, whether or not you realize that you or your colleagues have made choices about what you're going to use. And that's your complexity today. But it gets more, because not only do you have complexity on your desk, all right, let's put that to one side. You have your CI/CD pipeline. So as soon as you have booked in your changes into GitHub, your CI/CD system replicates the wrong word, imitates what you've done on your desk in its own manner. And the chances are it does it multiple times because you have stages. And you bring in more tools because you can't get those tools on the developer's desk. And your build system is a thing on its own. A whole bunch of different build opinions. Lots of build opinions. There's your build opinion. There's you write the code. What should it do? There's what the IDE says when you do Control-S. There's what your Maven process says when you build it, okay, etc. And then CI and CD. So loads of build opinions about about what your behavior, your application should be, okay? And all of that just to put it on a traditional server, okay? Now that's the old way of us doing things. Now let's add in what containers bring to us. More frameworks, more choice, more languages, you name it. All right? Oh, and containers, yes. So everything that you ran on your desktop, you now have a Docker version. You're running some subset of the things that you use to produce the application on your desk inside the container. Yes? And your Jenkins system is doing the same. Right? All to produce this immutable image. It turns out as we know, that the relationship between the code that you change as a developer and what ends up in the production image aren't necessarily related. And people can get into all sorts of problems because of this arc of stuff that we're inflicting on ourselves, right? And these have consequences. So as developers, we look at all these tools, these pipeline development tools. And when I say development, I don't mean developer. I mean the process of tooling that you use all the way through. And we go, gosh, there's all this stuff. It's complicated to install and set up, and it's just hard, and I don't know how to get that on my desk, and it's just, right? So we have our own versions of them. And the life cycle that we have here of trying to create these things is complicated. So we don't do what happens in the build system on our desktop. We do something less in self-defense. And the code that we use to drive everything, the things on our desktop, very often drives the whole process. Right? You look at a POM, Maven POM, it has all these sections. Right? All sorts of information gets hidden in the POM. Right? And you can do things. You as a developer can change things in ways that you weren't realizing the consequences. Okay? So you end up with all these steps that we go through, right? Because we're not certain that what the developer has done isn't going to break something. So what do you think the code should do? What does your IDE think? Control S has got a decision. What do you think when you run the Maven build? What do you do when you run it inside the Docker container? What does the CI/CD system do? Multiple times, because you're doing different stages, right? And then what actually happens? So I think it's more than ironic that us as developers who are supposed to be empowered by all this to get stuff done are actually still hampered, and probably more hampered, by the process that we're creating to manage this extra complexity. Okay? And guess what? It gets worse. It gets different. No, it gets worse. Building, testing, and deploying. Okay, how many people use Jenkins? Of course. I'd always like to say, who doesn't use Jenkins? And then we'll tell you to leave. But who uses Jenkins? Everybody. Well, no, not anymore. In the cloud, if you're deploying to a high availability system, you want no single points of failure. A common single point of failure is your CI/CD system. So that's not a good idea. So we're moving away from having CI/CD systems where you have lots of paths through, lots of build jobs related, and they do stuff, one server or set of servers, to this sort of approach. Lots of different pipelines related to the project that you're on, related to the container that you're deploying. Pipelines that are configured with, and I'll mention the tools in a minute, how you do your job, how that delivery takes place. Separate, self-contained, specific. Oh, and one more. If you think that's bad, the IT guys have it in spades, but even worse, because operating systems themselves are becoming containerized. And what that means is that the old way of installing software, which might be the moral equivalent of logging in and doing apt-get install DHCP server or something, is rapidly disappearing because containers can do that function, and servers will then are being instantiated, being told what they should be running, installed a bunch of Docker containers. So a whole bunch of the DevOps tooling that we're quite used to, Ansible, Chef Puppet, things like that, are going to find themselves having to reinvent themselves to fit into this sort of model. Containers are everywhere. So, yes, things are getting much more complicated, and to be honest, a lot of this complexity is necessary because of what we're trying to do: high availability systems, scalable systems, resilient systems. But the trouble is, the tooling isn't keeping up. Nobody's particular fault. We're just charging ahead so fast and trying to make this happen. There are lots of people trying to get there to help the tooling keep up. So unfortunately, it's getting us a bit soaked. And if you talk to people and you go, hey, you're using Kubernetes? And it's like, yep, I'm using Kubernetes. Okay, what do you think of it? It's okay. Yeah. So it's complicated. But I'm not going to leave you there and say, hey, okay, we're done. Life's hard. No, we've got things that are happening. So what's happening? Well, Cloud Native Computing Foundation are bringing some sanity to this. Lots of projects are in this space. Lots of projects are in this space. And they're bringing them together, and they're creating roadmaps to try and bring some prioritization and some order to the structure. If anything I've said it resonates, then the CNCF is a place to go to start getting to see what's coming and where things are going. It's an important collection of information and people, because this is a drive for all sorts of tooling in this space. Okay. If you want to know more about what's happening in these pipeline spaces, Tecton, Jenkins X, same sorts of ideas, these pipelines of deployment specific for your container, the Linux Foundation are hosting those. They are a place to go look at. It's commonality. Can we construct alternatives that you can make use of? Can we make it easier for you to consume? Containers themselves are changing as well. If you think containers are Docker, that's true, and the way that Docker works is always going to continue to work. But the container space is changing too, because people want to explore different ways of creating containers, different tooling approaches, more levels of sophistication. So there may be projects as a place to go to see what's happening in that space. You may find there's stuff happening that will make your job easier. Right? Yeah. And then I get to, so what are we doing? So IBM created this Cabanero.io umbrella project. So we're trying to figure out where would we go to reduce the overhead on developers, and how would we go about creating a nicer experience for going from nothing to deployed code. And there's a whole bunch of stages, that whole pipeline. There's the things for development and the things for IT. So the Cabanero is an open source umbrella project. So what we're trying to do is figure out what bits and pieces we want in that umbrella, which bits are missing. We're creating some projects. Which bits are out that we're going, that's really good. Let's work with those guys to see how we can wire this stuff together. It's open source. This isn't a proprietary tool. This is, we need to solve this problem for everybody. We have some commercial interests, of course, but at the end of the day, this is, we need to solve these problems for everybody. So there's a bunch of stuff on here. You can see Red Hat CodeWin, IDE integrations, some interesting development tooling, some visualization tooling, and some others. But I'm only going to touch on a couple of those because we just don't have the time. And this will be more developer related to you. So let's talk about this one, Eclipse CodeWind. Hey, it's Eclipse project. Think about how your IDE works when you have a container. Quite often what your IDE does is, as an existing IDE, you do stuff in development, you compile it, you create a Docker image, you run it, you want to debug it, or you want to run some tool against it. It's complicated to make the connections. What CodeWind is trying to do is make it easier. The final objective of CodeWind is so that you won't know that everything that you're doing is happening inside a container. So what you want to be able to do is have an environment where your source code sits on your desk, but all of the build tools that you use, all of the build tools, even the stuff that the IDE does traditionally, like incremental compilation, all of that can be put in the container with a set of build tools. You don't have to install anything, and you get an environment that is completely self-contained and joined up to your IDE. So as far as you're concerned, you're just doing development as normal. Source on your desktop, IDE, compile, build, test, run performance tools, whatever. Wired in, completely seamless. So if you were looking at these sorts of the steps again, the idea is to take one level, to take all these tools that you have in the process, whatever they may be, and bring versions down to you. The simple idea is we should be able to figure out from what you're doing that there's a particular type of tool that you can probably make use of. So if you have a health endpoint in your application, wouldn't it be good if we could say, oh, you've got a health endpoint, let's give you the ability in your IDE to just fire up some monitoring tool and have it wired into the thing that you've got running locally inside the container. Just easier to get things going, right? And then, as I said, CodeWind also has the ability, because of the way it's working, to remove some of those build opinions and saying, hey, you've got less because you've got a Docker container that's got an opinion that you're relying on. So you don't have Control S, Maven, and Docker build opinions, you just have one. Okay? So CodeWind is trying to do that. CodeWind is trying to bring the tools and the containers together. CodeWind offers you existing stacks, so you can go to CodeWind and say, okay, I want to get started, I want to do a Java project using microprofile. You can get a stack which is already pre-configured with all the build tools needed to build it and some starting source code. That's cool, and it's wired together, and it's got some links to existing tools, so it can do some application performance monitoring, it can drive your endpoints, just try them out. Okay, it's just there. We know what you're doing. Why don't we just give you that tool? Okay, right. And then the other one I want to talk to you about is Absidy. So I like this. I think Absidy has what I call a twist that I think is going to make it interesting for the future. I think it's a really exciting way of exploring what you can do with containers. So this picture, all the different build opinions that make our life more complicated because we're testing out what our code does along the way. And you think about what happens on that thing. You've got different versions of Java. You may say, oh, okay, we're using Java 8 or 11 or whatever, but you're not, because you're using that version of Java 8, and 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 that version of that build tool. You have all that hidden complexity differences, and you have a bunch of build tools on top of that. CodeWind says, let's do it just once. Why don't we use containers to encapsulate one build opinion for everything, from the moral agreement of Control S, incremental compilation, all the way through to what your final build process looks like. Okay? It also does something else. I said to you about this, the idea that a lot of our choices are driven, a lot of the consequences are driven by what the code we have on the desktop. How about we don't make that anymore? How about we we step back and look at the code that we have on our desktop and say, how much do I need to do my day job? How much is metadata? How much have I got in here that I don't really need to see all the time? What about if I could take my code and split it into two? What if I could basically draw some arbitrary lines between my source code? What about saying, I have a bunch of dependencies, and those dependencies are expressed in the POM. Why don't I embed that in this stack? So that's the Docker that's the Docker image that does all the build for you. Why don't I leave those there? I leave that source code there. Let's leave all the metadata there. And then let's put in another template, right? Basically that, a set of code that you can use, where you put in the bits that you really care about. You put the tests or the business logic, right? And this isn't a Java story. You could do this for anything. So imagine that. So what you can do with Absidy is you can say, I want to start a project. Absidy init, name of a project. And this is all completely up to you. We have templates, but if you want to build your own stuff, you want to build your own stacks, your own templates, entirely up to you. The value is that you can create an environment where you've separated out the bits that you want the developers to use from the bits that developers don't want, you don't want the developers to touch. That's great for IT. I'm sure you can imagine IT guys getting excited about the idea and being able to manage the dependencies and do more audit control and stuff like that. And it gets out of the way of the developers. The developer doesn't have to worry about it. And if you do need the developer says, hey, this project needs an update, that's okay, you just get the stack rebuilt. You don't end up changing it accidentally and breaking something because it's a considered choice. So you can reduce into the template the starting activity. You can bake into that all the things that you care about as a developer or a team lead. Right? And then the next time you start a project, you can say, hey, we're going to base it on that template. That template's already set up for the IDEs we want to use. It's already set up for our authentication methods or our databases or whatever it's going to be. That can all be set up and baked into the template. And the bits that are important that you want to keep out of the hands of the developer, you can put in the stack. So Absidy init says, take that template and put it on your desktop. So now you have a piece of source code. It might not be very much. If it was Node, it might even be just one file which you can put an endpoint in. Because everything else, including things like Express Server and stuff like that, can be running in the stack. So the thing is, what Absidy's doing is when you run Absidy, it brings this stuff together. Right? It gives you a logical view of this code wired together. So within the container, your application continues to live as an incomplete entity, but it's separated out metadata in the stacks, code tests in the template, or in this case, in your code. Absidy brings it together. Okay. And the thing is, it doesn't stop here, because the last thing you can do with Absidy is you can do Absidy build, and you're going to get an image. That Docker image that you want to deploy comes out of that process. So you've put all your build tools into the process. You've got a separation between your build tool environment and your source code. Absidy will do incremental compilation connected to the IDE. It will do full build, and you will get the same result whether you run it locally or whether you run it anywhere through the pipeline. Okay? One opinion, immutable metadata. Developers can't change the things that they're not supposed to change. They can hack it, but it doesn't matter because the stack is a Docker image, it's a container, it's immutable. They can hack a live system, but they can't hack the one that you have in the registry. So that was just two of the tools that we're looking at to try and figure out how to make this pipeline just easier. Help manage the complexity, do our part to reduce the complexity that is the life of a container developer, the life of an IT developer who's looking after containers. Right. Bringing back opportunities for us to reduce the complexity, reduce the opportunity for error, and to be honest, provides some opportunities for the IT guys who need to provide some of the management, the audit controls. You imagine with things like Absidy has the dependencies in the stack. If you had a vulnerability dependency, what do? Normally you have to go through all your source code and change the POM and get it updated and do rebuilding. Okay? If your dependencies are in the stack and the build tools in the stack, you update the stack once and everybody gets it. Okay? So that's Cabanero. It's early days. We're at 0.4 or whatever for some of this stuff. I've touched on two of the developer tools. There are other pieces in there that you might want to have a look at. If you want to come and talk some more about it, come to the IBM booth and we'll give you a demo or two. And the other place to go look out for is the CNCF, because there's some cool stuff happening there. That's it. Thank you.